Once large debris and abrasive grit has been removed from incoming wastewater and preliminary treatment, it goes to the next process, primary treatment. The purpose of primary treatment is to remove the settleable organic and inorganic solids, floatable solids, and grease. Primary treatment is done by having the wastewater flow through sedimentation tanks. These tanks can either be rectangular or circular. Both types provide a quiescent or slow-moving flow. This quiescent flow allows solids to settle to the bottom, while floatable solids and grease rise to the top. The rate at which solids will settle depends on the size of the particle and its density. A large, heavy particle will sink to the bottom faster than a smaller, lighter particle. Primary sedimentation tanks are typically designed to remove around 90 to 95% of settleable solids and 50 to 65% of suspended solids. Some of those solids may be organic in nature, yielding a 20 to 35% reduction in biochemical oxygen demand. At this facility, there are 3 primary sedimentation tanks. Currently, only one is in operation, and the other 2 are provided for redundancy if the online tank fails. The wastewater enters the sedimentation tank through 3 sluice gates. Directly after the gates are diffusers. The diffusers reduce the high velocity of incoming wastewater and directs it perpendicular to the tank. This provides an even distribution of the wastewater while minimizing short circuits. This primary sedimentation tank has a sludge collection mechanism that provides 2 purposes. It rakes the solids that have settled to the bottom towards a hopper and skims the floating material to a rotary skimming device. Each primary sedimentation tank has 2 hoppers. This collection method is known as a chain and flight system. Fiberglass flights are connected to 2 continuous strands of fiberglass reinforced polyester chain. The flights are spaced at 10-foot intervals. A single drive mechanism drives a sprocket that engages the chains connected to the flights. The settled solids in the hoppers must be removed or they will continue to build up. Primary sludge pumps are used to pump the solids from the hoppers, sending the solids to an anaerobic digester for further treatment. An 8-inch plug valve, driven by an electric motor actuator, is located at the invert of each hopper. The valve opens and closes in conjunction with the operation of primary sludge pumps, removing the solids. The primary sludge pumps are controlled by the SCADA system using adjustable built-in timers. Controlling how often the pumps run allows operators to maintain an optimal sludge blanket in the primary tanks. Operators check the depth of settled material by using a sludge judge. Based on these physical results as well as laboratory results, operators can adjust the pumping cycles and timing to maintain optimal conditions. Typically, a sludge blanket of 1 to 2 feet and percent solids of 4 to 5% is desirable. If the sludge blanket is too low, then the percent solids will also typically go down because there's too much water. If the blanket is too high, then the operators are not pumping enough solids. This can cause the sludge to start going septic and create odor issues. Up top is the primary skimming facilities. This is designed to collect the grease and other floating solids from the sedimentation tanks. The flights push grease and floating debris toward a rotary skimmer just before the wastewater leaves the sedimentation tank. The skimmer itself is a 16-inch diameter stainless steel pipe with longitudinal slots cut in the top quarter section. Set collars seal the ends of the pipe yet allow it to rotate within the collar. An electric actuator drives a rack and pinion assembly, rotating the pipe either up or down. The skimmer pipe rotates downward until the lower edges of the slots are below the water surface of the primary sedimentation tank. To assist the removal of skimmings, a solenoid valve opens when the skimmer rotates down and initiates a flow of wash water to a series of spray nozzles extended across each tank. The wash water pushes the accumulated skimmings toward the skimmer, flowing over and into the skimmings pipe. The mixture of skimmings and wash water flow down the skimmer pipe by gravity to a pump station. The pump station consists of a wet well which receives the mixture of skimmings and wash water and a dry well which houses a pump. The skimmings process is controlled by timers in a local control panel. The mixture of wash water and skimmings are stored from anywhere between 1 to 12 hours. During this period, the floating debris and grease separate out and float to the surface. The water from the bottom of the wet well is pumped to the grit chamber. An ultrasonic level transmitter measures the level of skimmings and water. When the level reaches approximately 4 feet, the pump shuts off. With the water removed, the wet well now holds primarily skimmings. When the duration timer times out, the skimmer rotates up. The interval timer restarts, and the contents of the skimmings pump station are allowed to stand for another interval from 1 to 12 hours. Approximately 2 times a week, operators will manipulate the cycle to pump the skimmings to the anaerobic digester where they are further treated. The primary treated wastewater then leaves the sedimentation tank through the effluent weirs. It will travel by gravity to the next unit process where it will receive further treatment to reduce BOD, ammonia, turbidity, and numerous other water quality parameters as required by state and federal regulations.